The channel not only explains technology, it designs the future. If you want AI, data science, and real-world tech mastery, welcome to Technical Professor.
Hello everyone, welcome back to Technical Professor. So in this lecture, we are going to discuss about regularization and overfitting. So let's start it. So let me start with warning. So machine learning model fails. Yes, even smart models, even expensive models, even model trains all night long. And today we are going to learn why they fail and how to save them. So let's start it. So let's learn what is overfitting. All right. So let's learn what in overfitting. So so today agenda what is overfitting and underfitting versus overfitting and bias variance and trade-off. So why overfitting is dangerous? So let's start it. So now we are going to understanding overfitting. So overfitting is model when your model become too smart for its own good. That is overfitting. Okay. Smart for on good. Good. All right. So it memorizes training data like a student who memorize answers without understanding concept. So what will be result there? So lesson result. Perfect marks in practice and complete failure real exam. All right. So what is the training performance? So high accuracy on training data indicates potential overfitting, and test performance, that is poor performance on test data, reveal the model's inability to generalize. Okay. So now we are going to understand what is underfitting versus overfitting. Let's learn about. Underfitting is like a student who don't study. I will mention. Yeah, there it is. Perfect. Who's underfitting? Who don't studies. Overfitting is like a students who memorize the text word by word. So machine learning wants the middle path, understanding, node memorization. All right. What machine learning what? I will write there. Machine learning wants understanding. Choose not memorized. Okay. So now, what are real definition there? So models that are too simple but fail to capture underlying trends. And what is overfitting? So models too complex capture but producing noise instead of signal. All right. So now we are going to understand what are bias, variance, trade-off. So bias refers to the error due to our line simplistic assumption in the learning algorithm. So in simple terms, bias and variance are like two enemies. So high bias Model is too simple and always wrong in the same way. But high variance, too complex, work only on training data. And great ML models balance both. All right. So now we are going to understand why overfitting is dangerous. So overfitting looks amazing during training, but in real world, performance is disaster. So this is why many ML projects fail in production. So accuracy 99%, real world performance disaster. So overfitting can lead to unreliable predictions and poor model performances and high stakes also. In critical applications, overfitting can result in financial loss or safety risks. All right. So now we are going to understand models complexity inside. That is simple models. Simple models often generalize better, capturing essential patterns with minimal complexity. All right, so complex model may fit training data well, but risk overfitting to noise and outliers. And in model complexity, that is more layers, more parameters, and more complexity. Sounds cool, but complexity is double-edged sword. So more complexity is more chances to overfit. All right. So now we are going to understand what is generalization in ML. So the model's ability to predict unseen data is crucial, and real world impact is generalization ensure your model work effectively in real world scenarios. So the real goal of ML is generalization, not memorizing yesterday data. Uh, but perform well on tomorrow data. So model performance, model ability to accurate predict unseen data is crucial, but in real world also generalization of ensure that it should work on real world scenarios also. All right, so now we are going to understand regularization and complexity is there and penalty is there. Let's understand that. And what is regularization? Regularization is like telling your model, relax, don't try too hard. So it penalizes complexities to the model, say simple and general. So relax, don't try. So hard. And what is the penalty there? So regulation add a penalty to complex models, promoting simplicity and preventing overfitting. All right. And so now we are going to understand the regulation intuition. So in previous slide, yeah, yeah. So think regularization as speed limit. Without it, model goes fast and crash into overfitting. So with it, so if we apply regularization, then it will be smooth and better real performance. For example, if you are driving a bike and there will be no brakes, it will be crash with any other vehicle. But if we had a brake and front and back brakes, so it will when we want to stop, we can stop there, and when we want to run smooth, we can run smooth. So in this way, regularization is very important to us. All right. So now we are going to understand L1 regularization. So that is Lasso formula. So Lasso adds a penalty to reduce model complexity, and let's yeah, perfect. So L1 regularization, it is act as a strict teacher. If a feature is not useful, remove its completely. Remove it completely. This leads to feature selection and fewer features, cleaner models. So, all right. So, feature selection also helps in selecting important features effectively. So, if the any feature is not useful, it will remove it completely. All right. So, we can optimize our models by selecting features wisely and enhance performance through reduced complexity and achieve better generalization with power features. All right. Why L1 is powerful? L1 help when you have so many features and some features are useless. It simplifies your model and improve interpretability. So now we are going to understand L2 regularization overview. So ridge formula. So ridge regularization adds a penalty based on the clear values of coefficients. So weight shrink this technique reduce coefficient sizes, promoting simpler and more generalized models. All right, so regulation is more polite. Instead of deleting features, it says reduce the importance but not remove completely. It shrink weight smoothly. It will reduce only importance. And L2 keep all features but prevent any one of the four from dominating. So this lead to stable learning and better generation. So understand the importance of weight reduction, simplify models, and optimize performance through weight adjustments. So L1 regulation versus L2 regulation. So one feature selection, choose L1, and one smooth, stable model, choose L2. So many real system combine both. All right, L1 plus L2. Okay. So Regulation strength, it is lambda control how strict regularization is, and a low lambda almost no regularization. But if high lambda, very simple model. Choose lambda practice is critical. So you have to choose lambda correctly. All right. Now we are going to understand regularization in linear regression. So let's start it. So in linear regression, regularization prevents extreme weights, prevents extreme weights, and improve prediction stability. So without it, small noise can run the model. All right. So now we are going to understand regularization in holistic regression. So in classification, regularization avoids overconfident predictions and improve decision boundaries. So this is why a logistic regression always use regularization. And now we are going to understand regularization in neural networks. So neural networks have millions of parameters. So without regularization, overfitting happens. So with regression, training becomes stable, performance improve dramatically. All right. So with revision neural network, you can enhancing model robustness with dropout regulation. So dropout is a chaos on purpose. During training, random neurons are turned off. So this forces network to don't depend on neuron, learn robust patterns. All right. So why dropout works? So dropout is like a group study. If one student is absent, other will solve the problem. So that is the robustness. Okay. So early stopping. So early stopping is a common sense. So when validation errors start increasing, stop training, and more training is not equal to better model. So training curve is a visual model that is performance over time is crucial for early stopping. So optimal epochs also it identify optimal training duration help prevent overfitting and underfitting. Okay. So now we are going to understand database regularization. So in database, sometimes the best solution is more data, and more data it is reduce overfitting and improve generation naturally. So increasing data size improve model robustness and generation, and data augmentation also enhancing existing data throughout transformation boost model performance. All right. So now we are going to understand cross validation, and cross validation checks does my model perform well everywhere or only one lucky split? So it is A honesty test for models. Honesty test. Okay. So like k-fold, stratified. So it divide data into k subset for training and testing, and stratified ensure proportional representation of classes in each fold. So thank you so much for watching this video. So finally, today we are going to understand what are the final takeaway. I think previous left or not. No. So common beginner mistakes are for regulation is use complex model too early and ignore validation and train forever. So and regulation fix these mistakes. So if I want to summarize today's lecture, so what we learned today. So I we learned today is overfitting is dangerous and simple models generalize better and regularization control complexity and dropout and early stopping are powerful tools. Okay, so in next lecture, we are going to learn about hyperparameter tuning. So making model to be optimal. So if overfitting ever fooled you, hit like, comment hyperparameters for next lecture. Thank you for today. Bye bye. Take care.